Hello and welcome to our video on the unit circle. Now the unit circle is a useful tool to help us with advanced trigonometry. It's going to help us find the sine, cos of tan and tan of any angle, so for example sine of 30, without the need for a calculator. So this is really useful in your calculator free assessments, and it's something that you need to know about. So I've drawn a circle here on our Cartesian plane, and I've put here the unit circle has a radius of 1, so that means from here to here is 1, so we can label this point here would be 1, 0. This one would be 0, 1. Negative 1, 0, and 0, negative 1. Now, so you can see it's called a unit circle because unit means 1. So it's 1 all the way around. If we choose a point, and I'm going to call it P, and we can say this has coordinates. I've written it down here for you, x comma y. Which just means there's an x value and there's a y value. And theta is the angle from the x-axis. This should be from the positive x-axis. Forgot to include that. So there's your theta. Here's your point P. P could be anywhere on the circle, but I've put it here for the demonstration. What we find is you can redraw this triangle to find sine of theta. This length here is this length here. It's always going to be 1 all the way around the circle. This length here is just the whatever the x value is of this point P. So I'll just put x. This length here is going to be whatever the y value is of the point P. So I'll put y. So sine theta is opposite over hypotenuse, which is y over 1, which is y. So sine theta is this y value of the point P. Cos theta is adjacent over hypotenuse, which is x over 1. Forgot to label adjacent. There we go. X over 1, which is x. So cos theta is the x value of this point. Only works in a unit circle. Tan theta is opposite over adjacent, which is y over x, which we know this sine theta is y and cos theta is x. So y over x is the same as sine theta over cos theta. If you didn't know that, tan theta is always the ratio between sine and cos. Lots of new information here. I just want you to keep watching and it will come together soon for you. Next thing I need to talk to you about are how we can label these quadrants. See how there's 4 quadrants here? We label them by numbering each quadrant, and we always number them in this order. So we start with this top right quadrant and we go around in a anti-clockwise to number them. The other thing we need to look at, because we're talking about angles, this angle theta here from the positive x-axis, so we always start at the positive x and go around the same way as the arrow. So this will be 0 degrees where we start. We go up to here, this is 90 degrees. Keep going around to here, this will be 180 degrees. Keep going around to the bottom, 240, and if we go 1 full circle, we get to 360 degrees. So this can be 360 or it can be 0, depending on how far you've gone around. Really important to know these numbers because we're going to talk about things that happen in quadrant 1, quadrant 2, quadrant 3 and quadrant 4. First of all, I want to talk about quadrants number 1 and 2. We've talked a bit about quadrant 1. I want to talk a little bit about angles in quadrant 2. Remember from what we just talked about that sine theta is the y coordinate, cos theta is the x coordinate. So let's take our P again here, and this time, so P is in quadrant 1. This time I'm going to make another angle in quadrant 2. That would normally be a straight line. So P this time is going to be at 40 degrees from the positive x-axis, and Q is all the way around here. Remember, we start from the positive x-axis and go all the way to Q, and Q is at 140 degrees all the way around. What I'd like you to have a go at is finding these values here. You can pause and have a go, or you can continue watching. To find the x-coordinate of P, we just need to do cos of the angle from the x-axis, and we can work that out to be 0.77 using our calculator at the moment. The x-coordinate of Q over here is going to be cos of 140, which using your calculator is negative 0.77. The y-coordinate of P up here is sine of 40 which is 0.64, and of Q sine of 140, which also equals 0.64. Interesting. Lastly, we're looking at tan 40, which we know tan from earlier. I didn't put it here, but tan theta equals sine theta over cos theta. And And we already know that for 40, sine theta is 0.64. And for cos theta it's 0.77, which equals 0.84. You could put that straight into your calculator as well, and you should get 0.84 as well. And cos 140 is going to be 0.64 divided by negative 0.77, which is negative 0.84. Okay, what does this all mean? What we found out is that for both of these angles, and when I drew it I intentionally made them so that they are directly across from each other, so the y value should be the same. For both of these angles, they get similar results for sine and cos and tan. But we have got this slight difference here with cos is negative for Q, the one in the second quadrant, but positive for this for P. Sine is positive for both of them. Tan is positive in the first quadrant, and negative in the second quadrant. This is one thing that you will need to remember. I'm doing a quick jot here of your unit circle. And we have quadrant 1, quadrant 2. What you need to remember is that in quadrant 1, all sine, cos and tan. So P, remember, was in quadrant 1. Cos is positive, sine is positive, and tan is positive. So all three of them are positive. In quadrant 2, only sine is positive. So we put an S. And I'll teach you a way to remember that a bit more clearly when we do the other few quadrants. But for now you just need to remember all of them are positive in the first quadrant. Only sine is positive in the second quadrant. The other two are negative. Something else we can notice happening. I'll put my P and my Q back again. And ideally, if you're drawing this as well, you want to make them so they are directly across from each other. When you have 40 degrees here and 140 going all the way around here, we can find this little angle. I'll call that theta, green theta, by doing all the way around here, which is 180. Take away this bit, which is 140. So this theta is 40 degrees as well. Have a look at this. This is 40, this is 40. So what we could have done up here, instead of doing cos of 140 for Q and sine of 140, we could have just used what we already had here, because we know that 40 degrees is the same as, will give us the same solution as 140. And this is really important that we can do this. What we find is all the angles in quadrant 2, this is 2, this is 1, all these angles in quadrant 2, you can find a reference angle, it's called. So this 140 degrees, find the reference angle, which is this little bit here, and then work it out in quadrant 1. So everything refers back to something in quadrant 1. Let's try an example of using that.